Hello, and welcome back to CS631 Advanced Programming in the Unix Environment. This is week 5, segment 2, and as promised, we'll begin our discussion of the Unix programming environment as an IDE by looking at perhaps the most critical component, the tool that you spend most of your time with, the editor. To remind you what we said in our introductory video for this week, the Unix userland is in fact an integrated development environment, and we'll try to provide a reasonably quick summary of each of these components in this week's videos. And just for orientation, you are here. So let's get started. The code editor you use is your most important tool. It is where you will spend most of your time, both writing code, reading code, staring at code and wondering why it's not doing what you think it should be doing, and maneuvering through code. You'll be opening multiple files, comparing code side by side, copying code and formatting code. Every programmer has their favorite editor, of course, and many holy wars have broken out on the internet about which editor a real programmer should use. But I'll let you in on a little secret. It doesn't matter. Use what works for you. Use the tool you like best, that you are most comfortable with, that lets you be the most efficient. Just make sure you know your editor well, that you learn what it's capable of. There's a number of core features that you should take advantage of, including things such as syntax highlighting for the different programming languages you use. Efficient keyboard operations, meaning you do not need to move your hands off the keyboard to do your work. Using the mouse or touchpad to click tiny icons and select options from deeply nested menus takes not only time, but leads to a mental context switch. Use keyboard shortcuts instead. You want to be able to mark and jump around in your code based on markers you may want to set, and use multiple buffers to copy, yank, fold, and otherwise juggle code selections or blocks. You need efficient search and replace functionality. Want to be able to display multiple code windows side by side or in any other configuration you might want. Your editor should offer some level of auto-completion for standard function calls, constants, and even repeat code blocks. Let you easily look up the documentation for the library or API you're working on, and allow you to filter input through external commands. All of these are basic features of a good programming editor, and functionality you want to get a handle on. Even if you already have a preferred editor, make sure you do not lazily work around what you don't know, and instead invest the time to follow a good tutorial on the ins and outs of your editor. Now, let's take a look at a few specific examples of operating and using a decent programming editor efficiently. I'll be demonstrating some core functionality by example of Vim. Many, but not all, of the functionality shown here will also work for plain VI, and other editors will have functionally equivalent capabilities. First, let's talk about moving around code without using a graphical interface. That includes moving up, down, left, and right using the H, J, K, and L keys, which are on your touch type home row, so you don't need to move your hands away at all. By the way, the reason that we ended up with H, J, K, and L as the arrow keys in Vim is that Vim is derived from VI, and VI was written by Bill Joy, who happened to develop on a terminal that had a keyboard, and that looked like this. Note how this keyboard had the arrow keys placed right here on the home row. So that's why we, to this day, use H to go left, J to go down, K to go up, and L to go right. Oh, and note this key up here in the upper right? That's the home key, which also has the tilde character, which is why we use tilde as a shortcut or reference for the user's home directory. Anyway, so in addition to simple movements, we can jump around by words. Search forward or backwards, go to the beginning or end of a line, and page down and up using Ctrl D and B respectively. To center the current line in the middle of the screen, we can use ZZ, or use ZT, ZB to place it at the top or bottom of the screen. We can move around within code blocks and jump to the beginning or end, or flip through multiple files back and forth. So what does all this look like? Let's illustrate by example. Here we are using the code example from our CTEX tooltip. It is a variation of the simple shellcode example from our very first class. As I go through the example movements, you will see the key combination pop up in the bottom left. Okay, let's see. First, we're using Ctrl D to page down a few times. Ctrl B pages up. Ctrl D pages down. Now we're on this line over here. If we want to jump backwards, then we can hit Shift B to move backwards by whitespace boundary, or Shift W to move forwards. Lowercase b moves us backwards by word boundary, and lowercase w forward in the same manner. Writing code often makes us want to jump between code blocks, and one convenient way to do that is to use the jump to paragraph keys. If we hit open brace, shift and open bracket, we will jump backward one paragraph or code block. While closing brace will move us forward one paragraph or code block at a time. But we also differentiate code blocks not just by whitespace. Sometimes we want to know just within what larger logical block we are. For that we have a key combination of open bracket, open brace, which gets us up here to the opening of the while loop. Jumping forward by block, as we did, and then moving up line by line by hitting K, we end up over here. Now we're inside a different block, so bracket brace places us at the end of the if statement. Note that Vim automatically highlights the matching closing brace here, and we can easily jump to it by hitting %. We can move forward, jumping to the end of each word, and % again to the matching closing brace. If we know where we want to go, we can use search. For example, I write my functions such that the function name is at the beginning of the line, so I can easily jump to any function by searching for the beginning of the line followed by the name. But now I'd like to see a bit more context without having to scroll the window up and down, so I'll center my display around the current position of the cursor by hitting ZZ. I'd like to see the function prototype of the getInput function, but that is in a different file, the getInput header. I don't want to lose my context, so instead of closing this file and opening a new one, I split my current window. There. I can keep that split window open and return back to the bottom window by hitting Ctrl W twice. Now I'd like to view the while loop, so let's align the display at the top by hitting ZT. We can close the upper window, go to the end of the line by using $, jump to the end of this block via %, and then align this code block at the bottom of the display using ZB. Okay, so these were some examples of some of the most basic motion commands. Don't worry if you didn't keep track of all of these. Vim has a detailed built-in manual. Here, let's take a look at help motion.txt. Inside this help window, all the common Vim functionality works too. But this also adds something we haven't illustrated yet, jumping to a different files via special anchors. Here in this help section, if we want to look at text object motion, we can move to the index word on the right and hit Ctrl closing bracket, which jumps us to the relevant section. Here we see some of the motion commands we just discussed, and we can return to where we came from using Ctrl-T. So make sure to consult the manual when you forgot how to move around, or if you're thinking to yourself, wait, there's gotta be a better way to move within my code. Now, with basic motion under our belt, let's cover a few common editing tasks. In order to efficiently jump between arbitrary places in the code, we can set a marker to return to. When we have to move code around, it can be helpful to highlight and select blocks, to indent or format them automatically, and to delete or copy sections into a temporary buffer, and then to pull the code out of the buffers again. When we're working with large blocks of code, it can be useful to hide some logical blocks or a few select lines without actually removing them. For that, we can use so-called folds, and when we are writing code, we may want to ask our editor to autocomplete or at least suggest options. Again, let's look at a few quick examples. We'll use the same code as before to illustrate. First, let's have our editor display line numbers, because that can be useful. There, that's better. Now, let's go to line number 38. Let's assume that we are working here in this spot right now, so we probably want an easy way to go back here. Remembering line number 38 isn't too difficult, but we can also instead set a marker. To do that, we use the M key followed by the marker. Here we use MA to create a marker. Now that we have decided that we would like to move the code block installing the signal handler around, we go up, hit Shift V to enter visual mode, and then can highlight and select lines like this. To cut this code block, we can simply delete it. Hitting D will remove the visual block and place it into the default buffer. After that, we can go up to where we want to enter the code and simply hit P to paste the contents of the default buffer at the current cursor position. Yay! Okay, so now to jump back to where we were, let's use our marker. Remember, we had set marker A at line 38, so hitting apostrophe A will jump us back down there. But let's say we decided that moving the code around was a bad idea after all. We can of course now manually reverse the changes, but Vim also has a handy undo functionality. So let's use that. U to undo the pasting, U to undo cutting the code block, and we're back to where we were before. Now let's go back down here into our while loop. Let's say we want to fold the code block involving the if fork blocks here. Let's set a second marker at the end, say marker Q. Then jump up to the beginning of the if. In order to hide the code block here, we can now create a fold by hitting ZF. Folds can be created from any place to any other place and follows your movements. We will simply create a fold from where we are to the end of the else block, where we had set a marker. So if we then hit apostrophe Q, Vim will hide the lines of code in question, like so. Note how we can maneuver around the fold using our usual motion keys. Okay, so now let's insert some code here. Specifically, I'd like to add a test to see if the user entered the special shell built-in exit to allow them to exit our shell. Let's start. Tab. How shall we start? If we hit Ctrl N, then Vim will begin order suggestions. The first time, it correctly guesses that if might be a good start, so let's use that. Next, we know we need a string comparison, but which one? Let's start with str and hit Ctrl N again. strn case compare? Sure, why not? Let's compare our buffer to exit strlen, sounds good. There. Now the user can exit our shell without having to feed in end of file. Next, let's look at the code in full. So we unfold this code block by moving our cursor into the fold and typing ZA. Looks good. Let's write the file. Okay, so now we made a change to our code, so we want to build the executable again. Let's see how our editor allows us to do that without having to leave it. A good coding editor integrates with the other development tools. Remember, Unix is an IDE. So we should be able to run our compiler or debugger and build our software from within the editor. For that, we will take a look at the make functionality that by default will, as the name suggests, run the make command, and look at how we can address any errors the compiler discovered using different shortcuts. Let's start by typing :make. So our edit window disappears, and we get the output from the make command in the shell. This shows us that there's some error somewhere when I try to compile the file getinput.c. Now reading the error messages here, we can determine just what went wrong. We need to fix something in that file getinput.c. But we were editing simple shell.c. Fortunately, we don't have to exit that file. If we simply hit return here, then Vim puts us directly into the right line and column in the right file where the first error was encountered. Nice. But wait, by now I already forgot what exactly the error was. Oh, good, it's shown down here too. Only that's a bit truncated. Let's get the full current error by hitting CC. Okay, that's useful. Implicit function declaration. Let's fix that. For the implicit function declaration, we need the right header. And what is the correct header for the printf function? Let's look it up using the manual pages. If we hit Shift-K on a function name in Vim, it will automatically bring up the manual page. So let's give that a try. Wait, that's printf, but it's the shell command, not the library function. That doesn't help us. Remember, shell commands are documented in section 1 of the manual pages, library functions in section 3. Let's exit this manual page view, and then try again, this time typing 3k. There we go. Now we're in section 3 of the manual pages and get the correct documentation of the library function, which tells us that we need to include the standard IO header. Let's quickly check what the errors were that we saw by bringing up the full error list using CL. Look at that, the compiler even told us the right header. If only we had paid attention to the error messages. So it looks like it might be useful to keep the error messages visible and not have them disappear. So for that, let's call copen, and we get the error output in this little window at the bottom. Now we can fix the right header include up here, write the file, and run make again. Oh no, again we have some errors, but at least we see that we fixed everything that was wrong in getinput.c. The next error is in sig.c, so let's go there. Alright, Vim does that automatically for us. Neat. And note that it also automatically updated the error output window down here. So we can add the missing quotes at the end of the statement and try again. Damn, still some errors. Oh look, we're missing an argument. Let's add that too. Try again. Okay, fix that, and another error pops up. Now we're in our simple shell.c file. Oh, looks like we mistyped buffsys. Let's delete the extra f here. But wait, what exactly is buffsys? Where does that come from? We can try to jump to the definition of this constant by using control closing bracket, just like in the Vim manual. Oops, we didn't save our changes. Let's write them. There. Now, control bracket brings us to the definition of buffsys, and control T brings us back again. Okay, let's try to build our code once more. There we go. No errors. Everything compiled as anticipated, so we can close the quick fix window. Alright. I think this quickly illustrated how nicely the editor integrates into the environment and allows us to efficiently write our code and fix errors identified by the compiler. Of course, there are thousands of other things you can practice, and it'll take some time to get the hang of it. I recommend that you look up and follow a good tutorial for your preferred editor. As I said earlier, VI or Vim are just one example. I happen to use them because they're ubiquitous. I never have to worry about whether my preferred editor will be present on any given system, but if you have another preference, that's perfectly fine too. You should find that any other good editor offers very similar functionality. Finally, there are many other integrations of the editor with development tools. I've covered two of those in separate videos, the ctext utility and the screen multiplexer. Check out the videos on our course website or in this YouTube channel playlist and practice working with your editor. In our next video, we'll cover the default compiler chain and how we get from C code to the executable. Until then, thanks for watching. Cheers!